All right, let's get started on this one. This is from the 2014 International Exam. This is question number 1, and it's calculator active, so make sure you've got your calculator handy. We're told that Ruth rode her bicycle on a straight trail. She recorded her velocity v of t in miles per hour for selected values of t over the time interval 0 less than or equal to t less than or equal to 2.4 hours, as shown in the table above. Okay, and we're also told that v of t is greater than 0, so she has positive velocity. In part A, we're asked to use the data in the table to approximate Ruth's acceleration at time t equals 1.4 hours and show the computations. Well, we know we've got velocity, and that's v of t, and we should know at this point that the way that we get acceleration a of t is to find the derivative of the velocity. Now, if we had a function for the velocity, we could use product rule, quotient rule, chain rule, whatever, to find the derivative. But we weren't given that. What we need to do is we need to approximate the acceleration. We need to approximate your derivative, right? Your slope of tangent line. And the way that you're going to approximate the slope of the tangent line is you're going to use the slope of a secant line. The difference between the two is that a secant line passes through 2 points, a tangent line passes through 1 point. So we want to approximate the velocity at time 1.4. Sorry, not the velocity. The acceleration at time 1.4. And the way that we're going to do that is we're going to look at our data table, and we have to pick values of t that are as close to 1.4 as we can get. So I'm looking here at time 1.2 and 1.6 seconds, and we're going to say that the derivative, the slope of the tangent line, is approximately what we get by looking at the change in the velocity from 1.2 to 1.6 seconds divided by the time interval 1.6 minus 1.2 seconds. The velocity at 1.6 is 16.3. The velocity at 1.2 is 17.2, and we're going to divide by the difference of 1.6 minus 1.2. If you work that out, you're going to get negative 2.25. Now, what are the units? The units in the numerator for velocity are miles per hour. The units in the denominator for time are hours. So this is miles per hour, or miles per hour squared. The College Board awarded 1 point for the approximation of negative 2.25 and 1 point for the correct units of miles per hour squared, for a grand total of 2 points. Couple things I want to point out is you could have stopped at this expression 16.3 minus 17.2 over 1.6 minus 1.2. That's a safe stop because everything is a numerical value. You cannot stop here because you still have the velocity at 1.6 and the velocity at 1.2. You want to show this work so that the College Board understands that you know to approximate acceleration, you look at change in velocity over a time interval, and you can stop here. Okay, so that's part A. Let's look at part B. In part B, we're told, using correct units, interpret the meaning of the integral from 0 to 2.4 v of t dt in the context of the problem. Okay. Then we're told to approximate that using a midpoint Riemann sum with 3 subintervals of equal length. All right, well, let's see. The integral from 0 to 2.4 of v of t dt. V of t is your velocity. When you find the definite integral of velocity, what you're normally getting is displacement, your change in position from your starting point to the final point. And so it would be 100% acceptable to say that this represents Ruth's displacement. Don't stop there. Mention the time interval. From t equals 0 to t equals 2.4 hours. And then you need to tell me what the displacement is being measured in. The velocity is being measured in miles per hour. Time is being measured in hours. Miles per hour times hours, the hours are going to cancel out, and you're going to get miles. So Ruth's displacement measured in miles. Now you might remember earlier they told you that the velocity, Ruth's velocity this whole time, is always positive. So you could also say that since her velocity is positive, the integral is not just her displacement, it's also total distance traveled. So you could say it's Ruth's total distance traveled from t equals 0 to t equals 2.4 hours, again measured in miles. I'm pretty sure that the College Board would give credit for the displacement answer, but on their scoring rubric they really wanted to see total distance traveled. The interpretation, whether it's this way or this guy here, was worth 1 point. Now for the approximation, what you're going to have to do is you're going to have to pay attention to the method. They said using a midpoint Riemann sum with 3 subintervals of equal width. Well, what do we know? We know that we are looking on the time interval t equals 0 to t equals 2.4 hours. So the width, the change in time, since each of these is going to have an equal width, is going to be 0.8 hours. And I want to be careful because we're doing the midpoint method. So let me do an exaggerated timeline here. We're going from 0 to 2.4 with 1, 2, 3 equal intervals. So 0, 0.8, 1.6, and 2.4 hours. But be careful because you're going to use the midpoint for each of these intervals to determine the height of the rectangle or the velocity. So we're going to look at time 0.4, time 1.2, and time 2.0. Your integral from 0 to 2.4 of v of t dt is approximately, you take the width of the interval 0.8 times the velocity at time 0.4 plus, for the next interval, the width, which is 0.8 times the velocity at 1.2 plus, for the third interval, the width is 0.8 times your velocity of 2.0. Well, what do we know? We know the velocity at time 0.4 is 11.8 miles per hour. At time 1.2, this is 17.2. And at time 2.0, the velocity is 16.8. You don't have to multiply all of this out, but if you do, you're going to get 36.64 miles. The College Board awarded 1 point for the setup of 0.8 times velocity at 0.4 plus 0.8 times velocity at 1.2 plus 0.8 times velocity at 2.0, and then 1 additional point for either this version where everything is just multiplied out but we haven't actually done the computations, or the final answer for a grand total of 3 points. I would hope that Part B would be a really comfortable problem for almost all students to complete. All right, let's move on to Part C. In Part C, we're looking on the same time interval, 0 to 2.4. Ruth's velocity can be modeled by the function g of t equals 24t plus 5 sine 6t over t plus 0.7. Okay, so now we actually have a function to represent her velocity. According to the model, what was Ruth's average velocity on the time interval 0 to 2.4? Well, one of the things that you need to remember is that when you're going to find the average value of a function on a time interval, you're going to integrate the function on that interval, and then you're going to divide by the length of the interval. Some students like to think of this as it's 1 over b minus a, the integral from a to b of f of x dx. That's great. These are equivalent. Well, how do we find average velocity? The average velocity then is going to be your integral from 0 to 2.4, your function g of t, and then we're going to divide that by the time interval 2.4 minus 0. Now, to actually do the integration to determine the value of the definite integral, we're going to need to go to the graphing calculator, and that's okay because this is a calculator active question. So let's do that. Let me see if I can switch screens here. Hopefully this is still recording. And I'm going to go over to my graph screen. And we're going to type in the function. Okay, the function is 24t plus 5 sine 6t. Now, of course, on my calculator, I'm going to have to change the t's over to x. And then I'm going to divide by x plus 0.7. Okay. Now, I don't actually need the graph. I just need the function in here so that I can do my computations. Let me switch over to the graph screen, and I'm just going to type in that definite integral that we just had. We're going to do menu, calculus, numerical integral from 0 to 2.4. The function that I typed in was f1 of x. I'm going to integrate with respect to x, and then I've got to divide by 2.4 minus 0. And good news, my answer matches the College Board's answer. So 14.064 is the final answer. Let me switch back so that you can see what I'm going to write down here. This is approximately 14.064. Because this is still velocity, the units are going to be miles per hour. College Board awarded 1 point for the integral of g of t dt from 0 to 2.4, and 1 point for the numerical answer, even if you did not include the units. That is 2 points. Let's look at part D. In part D, what do we need? In part D, we're told that according to the model in part C, is Ruth's speed increasing or decreasing at time t equals 1.3? Well, to figure out if speed is increasing or decreasing, I need to look at two things. We need to look at the velocity at time 1.3, and we need to look at the acceleration at time 1.3. Now, hopefully you know that if the velocity and acceleration have the same sign, then your speed is increasing. If the velocity and acceleration have different signs, then the speed is decreasing. Well, where am I going to get these numerical values? We're going to go back to the graphing calculator and see what we can come up with. So let me switch. This time I need the velocity at time 1.3. So that just means evaluate the function. And I'm getting 18.096. We also need the acceleration. Well, remember how you find acceleration is to find derivative of the velocity. So we're going to go to menu, calculus, numerical derivative. We're going to find the derivative with respect to x at 1.3. And we're finding the derivative of the velocity, which is f1. And we get 3.761. So my velocity is approximately 18.096. My acceleration is approximately 3.761. Putting these two together, we'd say speed is increasing at t equals 1.3 because v of 1.3 and the acceleration at 1.3 have the same sign. You Want to make sure that you're being specific here. We're talking about velocity and acceleration at 1.3. Normally, they're going to give you 1 point for considering velocity and acceleration at the given time, and then 1 more point for your conclusion. And that's it with Part D. Part D is 2 points. That closes out question number 1. I hope you did well there.